Welcome back to Networking Explained channel. In the previous videos, we explored what endpoints are, how they are identified, the roles they play, and how their state affects network behavior. Now, we are going to focus on a more subtle but extremely important concept: endpoint independence. Endpoint independence describes the degree to which an endpoint can operate, communicate, and change without being tightly coupled to other endpoints or to the underlying network structure. In simple terms, it answers this question: how much does this endpoint depend on everything else around it to function? In early networks, endpoints were often highly dependent. A device might rely on fixed network paths, static addresses, and tightly controlled communication patterns. If the network topology changed, endpoints often failed or required manual reconfiguration. Modern networks aim for the opposite. They are designed so endpoints can be independent, flexible, and resilient. An independent endpoint does not assume where other endpoints are located. It does not rely on fixed network paths. And it does not require direct knowledge of the internal structure of the network. Instead, it communicates through abstraction. For example, an endpoint may connect to a service name rather than a specific IP address. It may rely on discovery mechanisms, load balancers, or gateways to reach other endpoints. From a network behavior perspective, this independence is critical. When endpoints are independent, networks can change underneath them without breaking communication. Routes can be updated, infrastructure can be replaced, endpoints can be moved, scaled, or restarted. The endpoints continue to function because they are not tightly bound to those details. Endpoint independence also plays a major role in scalability. In large networks, especially cloud and distributed environments, endpoints appear and disappear constantly. If endpoints were dependent on each other's fixed locations or life cycles, the network would become fragile and difficult to manage. Independent endpoints allow systems to scale horizontally. New endpoints can be added. Old ones can be removed. Traffic can be redistributed dynamically, all without requiring changes to every other endpoint. Security is another area where endpoint independence matters. When endpoints are independent, trust is not assumed based on network location. Each endpoint must authenticate itself. Each request is evaluated on its own. This aligns closely with modern zero trust principles, where endpoints are treated as isolated actors rather than trusted members of a shared environment. Endpoint independence also reduces failure propagation. If one endpoint fails, becomes overloaded, or is compromised, independent design limits the impact on others. The network can reroute traffic, replace failed endpoints, or isolate problematic ones. This is a key reason why modern network architectures emphasize loose coupling between endpoints. However, endpoint independence does not mean endpoints are unaware of each other. It means they interact through well-defined interfaces and behaviors, rather than direct dependency. They follow protocols. They respect contracts. They rely on the network to handle discovery, routing, and policy enforcement. From a professional networking perspective, endpoint independence is not a single feature. It is the result of multiple design choices: address abstraction, service discovery, dynamic routing, policy-based access control. Together, these allow endpoints to focus on their function while the network adapts around them. Understanding endpoint independence helps explain why modern networks are more resilient, scalable, and secure than traditional ones. It explains why endpoints can move across networks, migrate between environments, and continue operating with minimal disruption. Endpoint independence is not just a design goal, it is a foundation of modern network behavior.